Hey guys, just Mr. Pettit here, looking at our trig ratios again, looking at our examples that we looked at. Didn't hear from Lottie, so it tells me that you understand most of the stuff that we're looking at. Creating those triangles, solving for angles, solving for sides, using Pythagorean theorem, using our Pythagorean theorem. And as long as you have a right angle and you've got two sides, if you have, say, two sides that you're given, you can use Pythagorean theorem to find that third side. And again, that was one of the key things that I noticed on some of the questions there. You did have to use Pythagorean theorem to find that third side and then start looking at your angles. Okay? With your note today and with your worksheet, it starts talking about the sine theta equaling 8 over 17. They want the primary ratios for this. So really what it needs you to do is, it needs you to find that triangle and opposite. So my sine theta, my theta is down here. I'm going to say my theta is right there. And my 8 and my 17 are right here. Opposite over hypotenuse. Okay? So we're looking at that in that format. So what we need to do here is we need to find that other side length right here. So I just make that x. X squared equals 17 squared minus 8 squared. Again, because I have the hypotenuse directly across from the right angle, what I need to do there is subtract because I know that value is going to be smaller. So I take my 17 and I square it, subtract 8 squared, and I get 225 as my value. So x squared equals 225. I square root that to get my x value, and I get 15 as my number here. So 15. So now, when it talks about finding the other primary trig ratios for that, now I can do this. Cos theta equals 15 over 17, and my tan theta equals my opposite, which is here. Here's my hypotenuse, and here's my adjacent. And tan theta would be 8 over 15. Okay, so there's two other examples there that I want you to take a look at, and you can go through those. Again, what you got to do is create your triangle, identify those locations where they need to be, and then use your other primary trig ratios to figure those out as well. Okay, the next part. The next part is your secondary ratios. So your secondary ratios are really just the flip version of your primary ratios. So in the example that we have here, we have sine theta equaling 3 over 4. Well, the one that's combined with this is our cosecant theta, which would be 4 over 3. Okay? Cosecant and sine are matched up together here. Our cosine is 7 over 11. Our secant theta would be 11 over 7. And our last one we have is tan theta equaling 8 over 3. And we have our cotangent, which would be 3 over 8 as our value. So really what we're doing is just flipping the actual ratio itself and just showing that it's going to be the flip version of this. Okay, so just giving you examples of those, the secondary. So again, making sure you know the matchups, make sure you know what uses what in this sequence. So when it talks about cotangent, we can also refer it back to tan. If it's talking about cosecant, we can refer it back to sine. And looking at it in that format here, because really you don't have your cosecant, your cotangent, your secant buttons on your calculator. So what you have to do is you have to refer them back to those primary trig ratios in that case. Okay? I have some examples there for you. First example that we saw was cosecant 17 degrees. And what we need to do here is we need to take and find that value. So to find that value, what I need to do is I have to flip this. So I got to do the 1 over sine 17 degrees. So I'm flipping this whole format here, flipping the ratio, and now what we're going to do is we're going to find out our value. So 1 over 0.2924. I took it to 4 decimal places, and so our final value for this is going to be 3.408 as my value, as my number here. Okay, so what I'd like you to do is do the exact same thing to the rest of the equations there and some of the questions you're looking at, and it wants the values to 3 decimal places. At the very bottom with the angles, the same idea, the same concept here is you're looking at the first one. We have cosecant again, and we're looking at 1.624. Well, again, we talked about this. We in our first page that we're looking at, we had our questions. Well, we had something like this. We had sine theta equals 0.2092 or something like that. To find out our values, to find out our theta, what we did was we did the inverse function of that and found out what our value was and found out what our angle was. Well, the same thing goes here, but what we got to do here is, for our angles, is we just got to take the theta and we're going to do the inverse of sine, and we're going to flip this. 1 over 1.624. We get our inverse function of that, and that's exactly what you type in. You type in the inverse function of 1 over 1.624, and we get 38 degrees. Okay? So, take a look at those questions, and if you have any questions or anything like that, or confused about some of those things as well, what you want to do is give me a shout on Thursday. We'll have our Google Meets, go over some of those questions as well, and get you caught up with that. Again, if you can't meet with the Google Meets, email me and we'll figure out a time when we can figure that out, and we can still do some of the questions as well and go from there. All right, guys. All right, stay safe, guys, and we'll talk to you soon.